Welcome back. We've been looking at writing linear equations. In this example, we're going to look at writing the equation for a line passing through the point 2, -7 and 3, -3. I want to write my answer in slope-intercept form, but I don't know my slope or my y-intercept. So I think I'm going to start with point slope. I still don't know my slope, but I do have a point on the line. So I'm going to start by finding my slope. That will be my first piece. So to find my slope, y2 minus y1 over x2 minus x1. Doesn't matter which point is 2 and which point is 1 as long as you are consistent. So my slope here, I'm going to take this point to be 2, this point to be 1. So y2 is -3 minus y1, which is -7, divided by x2, which is 3, minus x1, which is 2. -3 minus -7, this becomes plus, is 4, divided by 3 minus 2 is 1. So my slope is 4. I can pick either of these points to write my equation in point-slope form. It doesn't matter which point. I think I'll choose this point though. So I'm going to have y minus 2 is equal to my slope, which is 4, times x. Oh no, my y is -7. You got to be careful to make sure that you're putting the y in for the y and the x in for the x. So my y1 is -7 and my x1 is -2. No, it's +2. I'm sorry, so it should be x minus 2. So y minus -7 is equal to 4 times x minus 2. So this becomes y plus 7. Let me rewrite that out. So y plus 7, I'm going to distribute that 4 in, will give me 4x minus 8. I'm going to subtract 7 from each side, and y is equal to 4x minus 15. This is the equation of this line in slope-intercept form. Now the equation of this line, every point on the line should make a true statement. So if I take this ordered pair and plug it in, I should get a true statement. And I want to try that out. I want to see if that works. So I'm going to take my point 3, -3 and substitute it in. So my y value, so I'm substituting in 3, -3. My y value is -3. 4 times 3 minus 15. When we're checking, we don't want to mix things side to side. I want to keep everything that's on the right and everything that's on the left on the left. 12 minus 15, -3 is equal to -3. That is a true statement. This equation checks out. We're going to use that idea in our next example, which is an equation of the line that passes through the points 4, -9, and 2, -4. I have 4 equations here, all in slope-intercept form. Both points, when plugged in, should make a true statement. But I don't think I want to start there. I want to start by checking the slope, because you'll notice I have 2 that have the slope of -5/2 and 2 that have a slope of -2/2. So one of these slopes is correct and one of these slopes is not. And if I can figure that out, I can quickly eliminate 2 of the options. So let's find my slope. y2 minus y1 over x2 minus x1. So that'll be -4 minus -9 divided by 2 minus 4. So I took this point and subtracted this one. So -4 minus -9, that becomes plus. So -4 plus 9 is 5. 2 minus 4 is -2. So my slope is -5/2, which means the 2 points that have a different slope are not going to be on the line. I'm now going to take these points and check them in here. So if I check the point, I'm going to check 2, -4 in A. So -4 is equal to -5/2 times 2 plus 1. All right, Negative 4 is equal to negative 5 halves is negative 5 plus 1. This ends up being true. So now I'm going to check my other point there. Negative 9 is equal to negative 5 halves times 4 plus 1. All right, so negative 9 is equal to negative 5 halves times 4 will be negative 10 plus 1. That is also true. So A ends up being my answer because both of those points make a true statement when plugged into this equation. So this must be the equation of the line.